Everyone, and today we are going to look at the sum of the interior angles in a triangle and what they always sum up to be. So we're actually going to start by looking at this website here. I'll provide the link for you to play around with. But what we notice is if we move this triangle around so that the angles are changing size, what's happening is no matter how big we make this, whether it be obtuse or we move this around, we see it's got different, sizes. What we notice is no matter what, these angles are always summing up to be 180 degrees. And again, this is no matter what. When we start moving this around, we notice that sum is not changing from 180. So that's the focus of today's lesson, is that our interior angles are going to always be summing up to create this straight angle, which again, we know has to be 180 degrees. Now, how do we prove this for all of them? Well, it involves a little theorem, 210, that when we draw in parallel lines, we can always draw one through a point. There will always exist a line parallel to a given line. So we see this here, that you're allowed to draw that in. And again, we can use that to help us prove that these triangles have 180 degrees. And again, going back to another GeoGebra slide, we see this. So what we could do is we can draw in those auxiliary lines using that theorem we just talked about. And then from there, notice we create those alternate interior angles with those parallel lines to again show why they're always summing up to be 180 degrees. We're creating that straight angle. So again, that's the big theorem of the day, is that your three interior angles are going to sum up in any triangle to be 180. So again, that's kind of going through this proof more visually than working out using those alternate interior angles to be congruent. We could show that they create that straight angle of 180 degrees. So again, how do we use this? Well, if we are looking for the missing third angle in a triangle, what we can do is we could take our sum, 180, and subtract away the 2 that we have to find our remaining angle. So in this case, 180 minus 130 minus 22, our missing angle would be 28 degrees. In the second example here, notice we're trying to find this angle over here. The problem is we don't actually know the 2 out of the 3 angles. We only actually know 1 of them. So what we're going to actually do is solve over here first, because then we know that these are vertical angles and would be the same size. So if we take 180 minus the 45-degree angle, and then this would be a 90-degree angle, we would actually get this to also equal 45 degrees. And then from there, again, our vertical angles are congruent, so this would also have to be 45 degrees. And then finally, we can find our missing angle by doing 180 minus 67 minus the 45 to get our remaining angle of 68 degrees. We have a similar one to that down below. Now, of course, we oftentimes want to solve for x using a little bit of algebra using this fact. So notice we have 1, 2, 3 angles given, and we know that 2x plus 1 plus that 90-degree angle plus the 65-degree angle need to sum up to be 180. So again, we're going to start by combining down 1, 90, and 65. We would end up with 2x plus 156. And then we're moving across this equal sign. So we're able to undo that addition with some subtraction. So we get 2x equals 24. Divide by the 2, x is 12. And that's what we're looking for this time. Now, sometimes they are just going to give you visual, or they're not going to give you the visual. They're telling you, though, this is a triangle, and they're giving you the 3 interior angles, S, T, and U. So whether you decide to draw a picture or not, but basically we know that S, T, and U, those angles need to sum up to be 180 degrees. So we could take 10x plus 11 plus angle 2, which is x plus 6, plus angle 3. And again, those 3 angles need to sum up to be 180. Now, before we move across the equal sign, let's condense by combining our like terms on the left. So 10x plus 1x plus 2x are 13x's, 11 plus 6, but minus 6 is actually just 11. And then we can subtract the 11 over to get our x's more condensed by itself and divide by 13. X actually ends up being 13. And again, we know we're done because that's all it wanted us to find. You will occasionally have to plug back in, though, to find S, T, or U. All right, we have a final 2 examples for you to try on your own. The first one is asking you to solve for X. And the second one, again, did not give you a picture, but it, again, is giving you those 3 angles and, again, wants you to solve for X. Thanks, everyone, for watching, and we will work more with these in class.